Can you tell the difference between these two all cap blanks? The one on the right is titanium and the one on the left is aluminum. Okay, we're about to machine titanium for the first time. Got it all set up. Got my coolant on. So when you machine titanium, people generally recommend you to take very aggressive cuts, and I have used G-Wizard to determine what my speeds and feeds are and what my chip load should be, and it's very aggressive, so I'm not actually sure that this tool is going to be able to pull it off. It's not a brand new half-inch end mill, but it's pretty sharp. Actually, it doesn't look like a half-incher. I think that might be 3/8. You know what? I think that is 3/8. I'm glad I caught that. I need to rewrite my program real quick. We have the right program loaded up now, and like I said, our coolant nozzles are adjusted, and this should be fun. I'm pretty sure that my machine is not going to like what I'm about to do to it, and I'm probably maybe going to break something. Probably going to burn up a $7 chunk of titanium, but this is how you learn. Okay. Our spindle override is set to, this is actually 0% override. It's at essentially 100% of what the spindle and the feed rate are at 100% of what the machine, what the G-code tells it to do. If we go down here, we're at like 50%. If we go up here, we're at 150%. So right here, we're just right at our optimal speeds and feeds, and this is gonna be nuts. Here we go. Okay, so I didn't program the right depth. Okay, we're going to see some more rigid tapping awesomeness. You got to tap these holes. This is part of the fixture that's going to hold the titanium hull caps. We have to tap all 5 of these holes. Oh no. Apparently the torque from the motor turning at such a low RPM was not enough to turn the tap. So I'm going to be retapping this hole at a different RPM, and hopefully the motor will have enough torque. Okay, so we're editing the G-code here. We're going to take out this first, this is the code for the first hole, because we already did that one. I finished tapping that one by hand. And now we're going to change the RPM that it taps to 200 RPM. This is what it goes in, and it's going to come out at 300. Hopefully that added RPM will give it just a little more oomph, a little more torque. Not sure it has enough torque at the lower end of the RPM range. Now, I half expect to break this tap off in a hole, which actually kind of sucks. And now that I think about it, I think a better option would be to tap the hole at only a 1/2 inch. So we're just going to go to a 1/2 inch, and if I need to go deeper, I can do it by hand. If you're tapping by hand, you can break the chips. You can stop the tap, back up, and then move forward. So we have 4 holes here. I'm going to go in at 200 and back up 300, and this should do. And then if we need the holes to be deeper, we can just tap it by hand. I post that code. Let's try this again. So we're going to start at this hole. 1, 2, 3, 4. Give ourselves plenty of oil in our tap. This helps tremendously. Okay, here's an excellent illustration of why you should always watch your decimal points. Instead of telling the machine to tap to 0.5 inch, I told it to tap 5 inches. and it literally drove the tap all the way to the hilt and stopped. And that's when I hit the E-stop. So, the good news is that the machine has enough torque to tap as deep as I need it to, and the bad news is I need to be a little more careful in my programming. Okay, we have 3 holes left. We've tapped this one. I tapped most of it by hand. This one I tapped like 2 inches deep because I told it to tap 5 inches down. And these 3 have not been tapped yet. So I've written a program. We've got the depth set at 1.25 inches, and our inwards, our RPM on the down feed is 200 RPM, and our reverse RPM is 300. So we'll see what happens here. I set our feed rate override real low because I want to make sure I'm dead on. Here we go. Okay, that's probably far enough. That flip still stopped. Okay, so that one didn't work. I don't know why it didn't go all the way down. It was at the same RPM. I suspect that I have a suspicion. I have 2 holes left to try my theory out on. I'll explain it if this doesn't work. So there we go. Should go down to ½ an inch and then stop. Okay, that kind of worked, yeah, I guess. Well, they tapped those ½ an inch deep. I guess it just didn't have the torque to go any further, but I can tap the rest of it by hand. What I wanted most was that the bolts would be pointing straight out because this is part of the fixture. I needed to clamp the all caps in very square because there will be a lot of torque when I cut the titanium. Okay, so this is the first half of the fixture. The piece will kind of sit in this pocket here, and then we'll clamp it from the back, and then the end mill will profile the top of the all cap. And this is our clamping bar that we just cut. Put a lot of never sees on there to keep them from binding up in the aluminum. 6061 tends to smear a lot. So here are the 2 fixture plates side by side. Old fixture plate, new fixture plate. The old fixture plate worked well for all caps. It was quick and dirty. I could simply drop an all cap in here and tighten down this Mighty Bite clamp. And it worked pretty well, except for the fact that cutting the all cap entirely when it was in the upright position was kind of inefficient. And it's better to have the all cap in the position that'll be in here. When it's in this fixture, I'll be able to generate a more efficient tool path and cut down on the cycle time. So it starts off in the vise. I have 2 pockets, one here and one here, and the all cap blank fits inside there. And then it goes to this station. The 2 all caps go here, and then once they're done here, they flip over and then go into here, and the other side of the tab is chamfered. That's all this spot is for chamfering the back side of the tab. So there you have it. New fixture plate, est finitaste. That's Spanish for, I don't know Spanish. I'm finally getting around to finishing up these pull studs that Isaac cut for me on the lathe. I had to mill this flat facet right here and on the other side, and also shave off the top. And now these things have to go to heat treat. So I've been putting that off forever, and I shouldn't be doing it, but I'm actually using a couple of these without them being heat treated. I just use them to hold drills, nothing that takes any side load. But I'm still going to get them heat treated. It's just a question of putting them in an envelope and shipping them off. Something else I wanted to add before I let you go is that this vise is a giant, steaming pile of poop. I bought this vise back when I didn't have much money in my name. It's a Chinese vise, and it was like, I think maybe 200 bucks. And it served me well over the years. It's a great maybe hobby vise, but repeatability is crap. This set screw that tightens this jaw down gets loose, and the way that the soft jaws are, you can't take your soft jaws out and then put them back in and expect them to still be in the same spot. Like, you just have to cut new soft jaws every time you remove them. So I really want an orange vise, definitely budgeting that into the next project, because I think an orange vise here and an orange vise here would do wonders to make this a more efficient use of space, like a 2-station orange vise here and then here. I have an FFL, a firearms manufacturing license, and I really want to make AR-10 receivers, and I can't tackle the project right now with this vise because these jaws there's no repeatability. You know, I couldn't cycle out the jaws, not to mention that an AR-10 is going to take maybe 8 operations total, unless I use a 4th axis, and then it will be 3, which would be really nice, but don't have the money for a 4th axis. So for now, just saving up for orange vices and hoping to get rid of this vise. This is an AR-15 receiver I built years ago on my Bridgeport that I may or may not have told you guys about. This took, I think, 1 hour and 15 minutes of machine time on a 2 horsepower Bridgeport Series 1 CNC that I converted to run off of Mach 3. It was a great machine to learn on, but I had to change all of the tools manually, and something like this took, I think, maybe 13 or 14 tools. And it's a 6-op, and then obviously I had the magwell broached by a company in Chicago. So I've never actually built one of these. I really want to, but I just haven't had the time or the drive. Thread milled buffer tube hole. It's not bad for an old machine. A machine that never in a million years would have imagined running a tool path this complex. I've had this rolling around in my truck for the past 2 or 3 years. So yeah, there you have it.